Good evening, students. So, good evening, my dear students. So, welcome back. So, yes, I know this is a 12th session, but still, I'm continuing with the pending syllabus of your 11th session. Probably this Saturday, I'm going to take extra class, guys. Okay, that we can decide at the end of this session. I hope you're all doing fantastic today. So, how was the day, guys? How was the day? Exactly, Tanya. So today it is good, but tomorrow it is Monday. So as usually, work pressure. Yeah. Yes. Yes, Jyoti. No problem, guys. Don't worry about tomorrow. So we have to think about only today. Yes. So it's a great to see you all logged in for our 12th session of Big Data System. So as I told, I'm not covering 12 session concept. So today I'm covering the pending concept of your 11th session. So still we have 67 slides. I will try to complete the syllabus today. Otherwise, so this weekend, so Saturday evening, I'm going to take the extra class, guys. So is it okay for you all? Is it okay for you all? Yes or no? Yes. Okay. Thank you. So thank you for your cooperations. Yes, before we dive into the nuts and bolt of today's topic, so let me start with the quick thought. So there is a wonderful quote by the famous science fiction writer. So Arthur C. Clarke. So any sufficiently advanced technology is indistinguishable from magic. I hope everyone will agree with this point. Guys, big data systems and cloud computing. So which we will be what covering in today's session. Okay, so you can feel free exactly like that, guys, like magic that makes impossible things possible. But we as engineers and architects are here to demystify that magic and master the technology behind it. Okay. Yes, guys, with this, so let's bring that energy and curiosity into our today's session. Are you all ready for today's session? Can I get big ready and chat box? So once you people are ready for today's session, yes or no? Yes. Okay. So what about others? I want each and everyone to respond, guys. Okay, let me share my screen. So before that, let me connect through my mobile also, because if you ask any questions, then I will not get to know. So one second, guys. So I'm connecting by using my mobile also. Give me one second. So where is the chat box? Okay, guys. Sir, but recording shows 40 minutes. Which recording it is showing 40 minutes? No, it is showing 9 minutes only, no? So look at here. So how come it is showing 40 minutes? Okay, guys, yes. So yeah, I was talking about today's portion, right? So let me share my screen. So I think my screen is visible to everyone. Is it visible? Can I get quick confirmation on chat box? So once my screen is visible, please do type me visible on chat box. Guys, last class I have started with NoSQL concept. Okay, so under NoSQL, we have started with Cassandra. So I have started with 2 slides. Okay, so first slide and second slide I've completed. I have explained you with read or write operations and also the very first slide that was introduction on Cassandra. So today I'm continuing with the third slide, guys. So consistency semantics. Guys, actually, this is a very important point in distributed system. Okay, so make a note of this, guys. Cassandra consistency model is one of its biggest differentiators. See why I'm saying this? Because so there is no primary replica. That is the very first reason why we are all using Cassandra today. And Cassandra offers high partition tolerance and availability and level of consistency. Okay, so it even supports light transactions with linearizable consistency. Okay, let me show you here. One second, guys. See here, we have linearizable consistency. Okay. So what do you mean by linearizable consistency? So it is nothing but compare and set. Okay. The key mechanism is that a read or write operations can pick a consistency level here. And let's explore the most common ones, guys. The most common ones are, the very first one is 1, 2, 3, all. So this is the very first option. 1, 2, 3, all. Guys, there are simple counts. Okay, they require 1, 2, 3, or all replicas respectively to acknowledge the operation. Okay, so higher the number, so stronger the consistency, so slower the operation. So that is the trick behind this 1, 2, 3. And second one is any. So this is the most lenient write consistency. A write to any node, even if replicas are down, can be considered successfully. So this ensures maximum availability. And the third point is quorum. So this is the third point. I'm talking about quorum now. So this is very common balanced settings in Cassandra, and it requires a majority of all replicas to acknowledge. Okay, so if you have n replicas, you just imagine you have n replicas means the quorum would be always n by 2 plus 1. Okay, this is called as quorum. And next one, we have local quorum. Guys, the majority must acknowledge within the same data center. Okay, so this is crucial for multi-data center deployment for better local performance. So let me take one example to explain on this, guys. Imagine, okay, you have a cluster with 5 replicas. Okay, you have a cluster. So let me write cluster here. So with 5 replicas. Okay, then what is the value of n here? So n is equal to 5. Correct, no? So if you set the right consistency to this quorum, you need 3 replicas to respond, at least 3 replicas to respond. Okay, so this is the great balance, guys. So for a user profile view, you might use 1 of max speed. For critical inventory deductions, you might use quorum. Okay, so this ability to pick a consistency level per operation is Cassandra's way of giving you the control to balance C and A. C means consistency and A is nothing but availability. So let's see how we can use these levels to achieve stronger consistency model like casual consistency. Okay, so next slide I'm showing you about consistency semantics 2. So now let's connect these level back to the consistency model we studied. So specifically, we are going to call it as casual consistency. Casual consistency. Guys, to achieve a strong level of casual consistency, the golden rule of thumb in a system like Cassandra is to pick read consistency level equals to, see, look at here, read consistency level equals to write consistency level, that equals to quorum. So you can ask me why. Okay, because of the what? Quorum rule. What is the quorum rule? Quorum rule is R plus W should be always greater than N. R plus W should be always greater than N. Guys, at least one node will be common between the write set and the read set. So a read will be what? Guaranteed to get the last write of the data item. So make a note of this, guys. This is very, very important point. The quorum rule is the mathematical basis for achieving strong consistency guarantees in distributed system like Cassandra. So now let's consider a quick question. Okay, so what happens? This is the question I'm showing you here. What happens if read and write use local quorum? Guys, you achieve casual consistency within a single data center. So which is perfect for most regional applications. And finally, look at here, guys. So what if you read and write consistency levels are low and do not overlap? If no overlap read and write sets, then you only have eventual consistency. Okay, the system will converge over time, but there is no guarantee that your immediate read will see your most recent writes. Okay, so let me take an example to explain on this. Guys, in a customer shopping cart application. So I'm taking the example of customer shopping cart applications. Guys, you want casual consistency. Casual consistency is nothing but what, guys? Look, quorum, right? So where a user adds an item to the cart and immediately view the cart total. Correct? No? I think you all experience this, right? You will add everything into the cart and you can see the cart total also. Okay. See, for something less critical, like tracking products view, eventual consistency is fine. Okay. So understanding this balance is your secret weapon. Guys, moving on, let's look at how Cassandra handles more complex but rare transactions like needs. Okay, look at here, guys, everyone. So lightweight transactions. So we are going to call it as lightweight transaction. My dear students, while Cassandra is not an ACID compliant RDBMS, it does provide a capability for handling simple atomic operations through lightweight transactions. So in short form, we are going to call it as LWT. Okay, so LWTs are supported for insert and update with an if clause. Okay, so this gives you lightweight transaction semantics at the data item level. So often referred to as a what? Compare and set. Already I've told you about this, right? Compare and set. Okay, so in short form, we are going to call it as CAS. Okay, it checks the current state of the value and if it matches the expected value, performs the update. So however, guys, LWT is not free. Okay, it increases overheads by 4 times due to coordinations between nodes to guarantee linearizability. So use it for critical single item operations only, guys. So now look at the examples on SQL. Okay, so usually we are going to call it as Cassandra query language. So in short form, we are going to call it as SQL. Okay, it is not SQL, guys. It is SQL. Okay, so look at the conditions here. The very first conditions on, see, I'm taking the conditional insert here. Okay, this is the conditional insert. You just look at here. So this is the prompt you are going to get. So once you are entering into Cassandra. So look at the code here. Insert into cycling dot cyclist name, ID you are passing, last name, first name, values you are passing here. And if not exist, that is the condition you are mentioning here. Guys, here, this ensures the row is inserted only if the primary key. What is primary key here? The primary key is ID here. Correct, no? So this ensures the row is inserted only if the primary key does not already exist. Understanding my point, guys? And then what about condition update? See, condition update, look at here. Update cycling dot cycle list name, set first name is equal to Roxane. So where ID I have mentioned here, if first name is equal to some name I have mentioned. Guys, the name is updated only if the current first name property is this value. Okay, so this prevents a lost update scenario. Okay, Jyoti is asking a question. What is the question? What will happen if R plus W less than or equal to N? No, actually the architecture we have built like that, Jyoti. So the Cassandra will always support for R plus W greater than N. So it is not going to check with less than or equal to N. Is this clear, Jyoti? The entire architecture of Cassandra is built like that. Okay, so yes, let me take an example to explain on this, guys. Guys, you just imagine I am taking the ticket booking system. Okay, I'm taking ticket booking system. So what is the ticket booking system? Can anyone give me an example on ticket booking system? Any example on ticket booking system? Yes, anyone? Book My Show? Yes or no? Yes, Book My Show is the best example. BMS. Yes, IRCTC is also one of the best example. Redbus. Correct, no? These are all the example for ticket booking system. Guys, here. So in all these ticket booking system, you use this LWT. Why you are going to use LWT here? Because you have to what? Decrement the available seat count. So you would say update seats is equal to seats minus 1. Correct, no? Let me write the query here. So let me write the query here. Update seats is equal to, how you are going to calculate this? Seats minus 1 if seats greater than 0. Correct, no? Am I right or wrong, guys? So this is essential to prevent overselling. I hope everyone will agree with my point. Yes or no, guys? Guys, LWT is an important tool in the Cassandra toolbox, but use it sparingly. Okay, that is the suggestion I'm giving you at the end. Guys, now let us see how Cassandra manages fault tolerance with replication. So now look at the slide, guys. Look at this slide. I'm talking about a replication strategy for user data. Guys, to achieve high availability and fault tolerance, so data needs to be replicated. So hope everyone will agree with my point. Yes or no, guys? So we have to replicate the data. Yes or no? Shall I get quick confirmation in chat box? So if you people are saying yes, correct, no? Yes, guys, Cassandra offers different strategies for replication strategy for user data. What is the very first strategy? The very first strategy is called as simple strategy. Look at the first point here. Simple strategy. Guys, you specify the replication factor is equal to n here. And the data is stored in n nodes of the cluster. Very simple. So this is typically used for single data center cluster or for testing environments. And what is the second one? The second one is network topology strategy. Guys, this is what you must use for productions. Okay, multi data center deployments. Guys, this strategy allows you to specify the replication factor per data center. Understanding my point? So network topology strategy allows you to specify the replication factor per data center where you want reliability from data center failures. Then let us take one quick analogy to understand this. Guys, simple strategy is like having 3 copies of a book in one library. Okay, understanding my point? You have a library. In that library, you have 3 copies of a book. That is called as simple strategy. Guys, network topology strategy is like having 2 copies in the New York library and 3 copies in the London library and 5 copies in Bangalore library. If New York burns down, so London is safe. So hope everyone understood what exactly meant by simple replication strategy and also network replication strategy. So the example shows how to see, look at the example. So this example shows how to create a key space with this strategy. So what is the command here? This is the command I'm talking about, you guys. So create key space cluster 1 with replication class network topology strategy and East DC, West DC. See, East DC I have mentioned 2 copies, West DC I have mentioned 3 copies. So hope this is very easy to you all. Yes or no, guys? So once you people are feeling easy, please do type me easy in chat box. What it is maintaining, guys, here we maintain 2 replicas in East DC and 3 replicas in West DC. Very simple. Okay, let me take one more example to explain on this. Guys, a global payment processor needs a network topology strategy. I think everyone will agree with my point. If the DC in Asia goes down, all write operations can be quickly redirected to the DC in Europe. So which is ensuring continuous service. Guys, this level of control over where your data lives is key to building a truly globally available big data system. I think you all understood this concept. So is this clear to everyone? So if you have any question on this, please do ask me in the chat box, guys. I think till here everything is clear. Yes or no, guys? Is this crystal clear? You all with me? Okay, so the next step is understanding how data is distributed across these replicas in the first place. So which is handled by partitioners. Okay, so now I'm talking more on partitioners concept. Guys, already I've explained you what is the meaning of partitioners. Yes or no? The partitioners are responsible for distributing data across the cluster. They partitions data based on hashing to distribute data blocks from a column among nodes. Okay, the practitioner determines which node owns the initial copy of the piece of the data by hashing the primary key. Guys, we have 3 different types here. The very first type is called as random practitioner. So random practitioner is also called as crypto hash. Maybe you have heard about MD5. Crypto hash. So this random partitioners uses crypto hash and it provides a very even distribution, but so this is more expensive and range queries are inefficient. Then what is the second one? The second one is called as murmur 3 partition. Actually, they have not mentioned here. Let me write here. Murmur 3 partitioner, or we can call it as murmur. Guys, this is the default and recommended partitioners, guys. Okay, so it uses a non-crypto consistency hash, which is much faster. And it is 3 to 5 times faster and overall 10% of performance improvement we can observe here. So it offers a great balance of speed and even distribution. And what is the last one? The last one is byte order. Byte order partitioner. Okay. So guys, orders the partitions based on lexical order. Okay. Lexical order is nothing but what, guys? So it is nothing but alphabetical or numerical. Alphabetical or numerical. Okay. The main advantage of using this is efficient range queries. See, finding all data between key X and key Y because the data is co-located. But we have one disadvantage with respect to this, guys. What is the disadvantage? So this can lead to hotspots. If a large volume of data has keys that start similarly, then it will lead to hotspots. Okay, so all writes go to single node. That is one problem with respect to this. So let me take one analogy to explain on this, guys. So think of your primary key as a ticket number. Okay, the partitioner is the machine that decides which shelf in the warehouse to put the ticket numbers item on. Guys, Murmur 3 is the quickest and the smartest machine for this job. Okay, make a note of this, guys. This is very, very important. And the choice of partitioners will always decides your read or query request. Okay, so if you need range scans, you might tolerate the hotspots of byte order. Otherwise, so stick with the high performance of Murmur 3. So we will study this later in the context of Dynamo paper, guys. But for now, so let's look at some actual code examples. So next slide, I'm showing you a few code examples. You all look at here, guys. I want you people to concentrate here. Okay, so look at some practical CQL commands. The sample queries to solidify how we interact with the Cassandra. The very first command, see, very first command I'm showing you on creating a key space and table. Okay, how do you create key space and how do you create a table? See, look at here. So this is creating key space and this is creating table. Okay, so you all understood first three commands. Guys, we create key space DB. Key space DB. DB is nothing but what? Database. Key space is nothing but database here, guys. So switch to it and then create table. See, we are switching to it by using use demo. And then we are creating table. So what type of table we are creating here? So we are creating column family table. Okay, look at here, guys. So under that, the roll number int primary key we have taken is the crucial partition key. So this is the crucial partition key. I have told you, right? So we have to use primary key here. And where we are setting consistency, guys, look at here. So we are setting consistency here. Okay, consistency quorum, insert into something we are doing here. Guys, we set the session consistency to quorum and insert a row. So after that, we are going to insert a row. Note look at here. So you have to what observe here. So what I have mentioned here, I have mentioned using, where is using? Yes, using TTL30. What it tells, guys? Can anyone tell me what it tells using TTL30? Anyone? So which tells Cassandra to automatically delete this row after 30 seconds. Correct? No? Yeah, that is time to live. So after 30 seconds, it has to delete. So this is the great for temporary data. So hope everyone will agree with my point. And next one, selecting data. See, next command I'm talking about selecting data with warning. So this is, we are using for what? Selecting data with warning. Guys, this query on a non-key column requires allow filtering. Allow filtering concept we are using here. Okay, so you should avoid this in production. It forces a full cluster scan, so which is a very inefficient. Okay, so Cassandra is optimized for primary key lookups. Okay. And finally, what is the last one, guys? Can anyone tell me what is this last one? Last one is LWT example. Correct? No? Last one is LWT example. Okay. Update operation. So this is our compare and set LWT. Yes or no? Yes. Very good, Jyoti. Compare and set LWT. So this updates only if the condition name equals to Sam. Only the condition name equals to Sam is met. Okay, so hope everyone understood this. Now I'm going to take one analogy to explain on this, guys. Guys, the primary key is the index in the back of a book. Non-key lookups with allow filtering are like reading the whole book to find a single word. So these examples shows you the power and the pitfalls. Hope everyone will agree with my point. Now let us see a massive company that uses this power. So which company is going to use this power, guys? Can anyone tell me? Can anyone guess at least? Which company is using this? Any guess? So I've taken the case study of the same. Guys, eBay. Have you heard about eBay? Yes or no? Have you heard about eBay, guys? Yes, right? So this is the case that I'm taking here. My dear students, to truly appreciate the power of Cassandra, so let's look at one of the biggest e-commerce player. What is that? eBay. Okay. So eBay is a global marketplace with 100 million active buyers with 200 plus millions of items. So look at the sheer volume, guys. Look at the sheer volume. 2 billion 2 billion page view. 2 billion page views and 80 billion DB calls. And multi-petabyte storage capacity. Look at the sheer volume here. Guys, they handle 400 million plus writes and 200 million plus reads. Is it small, guys? You all wondered? See, I have mentioned that in this point. So this kind of scale requires a database built for horizontal scaling. Guys, Cassandra is perfect because in most of these interactions, there is no need for transactions. There is no need for joins. There is no need for referential integrity. Guys, eBay uses multi-DC deployment, multi-data center deployment, a perfect fit for Cassandra network topology strategy. How many of them will say yes for this? Yes or no? Which strategy we are using here, guys? Which strategy we are using? Can anyone type on chat box? Cassandra network topology strategy. Yes or no, guys? You all wondering? You all wondering, guys? And they use Cassandra for several key 3 use cases. See, here I mentioned only 3 use cases. The very first one is social signal on product pages. Guys, things like how many people viewed this here. And read latency is not important, but write performance is the key. So they have to record hundreds of millions of events immediately. Yes, exactly correct, Ravi Kumar. Your answer is perfectly correct. Okay. Yes, you people are typing correctly. And look at the second point. So connecting users and items via buy, sell, bid, watch events. Connecting users and items. Guys, this is tracking relationship via buy, sell, bid, and watch event. and many time series analysis cases such as fraud detection. So for fraud detection, we are going to use here. Let me take the analogy here. Guys, Cassandra is like a giant, guys. So lightning fast logbook for all activities on eBay. It guarantees that every event is recorded and available even at massive scale. So this case study proves that when you need a massive scale, high availability and immense write throughput, Cassandra is a top choice. Hope everyone understood this point. Now let us look at a case in a high stakes world of online advertisement. Okay, so I'm taking the example of AdStage. Okay, from your AWS use cases. So quickly I will go through this, guys. Let's look at AdTech. AdTech sector with a look at AdStage. Look at AdStage. Guys, AdStage is an online advertising platform to manage multi-channel advertisement campaign on Google. Okay, not only on Google, guys. So it is performing advertisement campaign on Facebook, Twitter, Bing, LinkedIn, so on and so forth. Guys, they have 3 clusters with 80 plus nodes on AWS. So, and also they are handling a vast amount of real-time data from 5 channels. Okay, so 5 channels. So their goal is to constantly monitor trends and optimize campaign for advertisers. Very simple. Then what are their requirements? See, they have some requirements, right? What are their requirements? The very first requirement of them is high performance and availability. This is the requirement, guys. This is the requirement. High performance and availability. And the second requirement is consistency is not critical as it is read mainly for reporting purposes. Okay. It's okay if the click count is off by one of the few seconds. The overall trend matters, guys. So this is an ideal fit for the AP model. Okay. So this is ideal fit for the AP model. Understand this. The main benefit is that Cassandra cluster can scale as more clients are added with the no spoof. So what is that SPOF? It is nothing but single point of failure. Single point of failure. So let me take an examples, guys. An advertiser needs to see their campaign performance in real time. Okay, then what this AdStage is going to do? Guys, AdStage needs to ingest billions of events per day and provides a dashboard with minimal latency. And speed and guaranteed uptime are far more important than million seconds of consistency. And these two case studies highlights Cassandra's sweet spot. So hope everyone understood why Cassandra is important. Now, at least anybody is asking you why Cassandra is important means now you are in a position to what answer to this question. Am I right or wrong, guys? Guys, now we have covered the columnar family database model with Cassandra. So let's transition to the most popular NoSQL category. So I'm taking the data document based one. So what is the document based? Can anyone tell me? Can anyone guess? That's all about Cassandra, guys. So now I'm jumping into the second one. What is the second one? And also it is comes under document database methodology. Answer is MongoDB, not DynamoDB, Jyoti. So yes, so we are starting with MongoDB first. Okay, so guys, look at here. So now Cassandra is over. We are jumping into the second one that is called as Mongo. Guys, your Mongo is ready in cluster. So you can access your virtual lab and you can work with MongoDB. Okay. So yes, regarding this, I will tell you later. Already I've uploaded all the worksheets. You just go and practice the worksheet. Guys, welcome back everyone. It's just a quick stop on our internal map to see where we are. So we have just completed a very detailed explorations of Cassandra, the column family database, and looking at its internal and real world applications, everything is done. So now we are shifting our focus to the next two major NoSQL types. So one is document database, that is nothing but MongoDB. And next one is graph database, that is Neo4j. So before we are moving into Neo4j, so let us start with the very first one, that is called as MongoDB. Guys, look at here. Guys, if Cassandra is the master of high volume event logging, then what is MongoDB, guys? MongoDB is the master of agility and rich complex data structure. Felt happy? And MongoDB is the most popular document oriented database. I think this is another what? Required concept, right? Guys, here the data is organized. See, the data organization is, what is the data organization here? The data organization is database is a set of collection. Okay, so database itself is a set of collection here. Then what do you mean by collection? Okay, note down here, guys, collection. Then what is collection? A collection is like a table in RDBMS. It is a kind of table, guys. A collection is like a table in RDBMS. Guys, then what collection stores? The collection stores documents. Okay, so similar to rows. Similar to rows. Okay, so look at here, guys. A document is stored in BSON or binary JSON with hierarchical key value pairs. I will take one example and I will explain you guys. No need to worry. So this allows you to nest data inside other data. Nesting also possible. And it is representing complex object in a single record. Okay, so let me give you some technical details here. What are the technical details I'm giving you here? Guys, max 16 MB document stored in WireTiger storage engine. See, for larger than 16 MB document, then what it is going to use? See, larger than 16 MB document uses GridFS. Guys, GridFS supports binary data by breaking large objects into chunks of 255 KB and storing metadata in a separate collection. And it does not support multi-document transactions by default. That you should understand. Okay, so let me take an example to explain on this. Let me take one small example. Guys, for a blog, a post content, comments, and author's details can be in one MongoDB document. So in an RDBMS, so this would be 3 tables and 2 joins, correct? No? But in MongoDB, so everything we are storing inside the same. Okay, so WireTiger storage is a storage, so which is going to use in MongoDB, which is having the capacity of 16 MB. So once the capacity of this document is higher than 16 MB, then we are going to use grid file system concept. So hope Ravi Kumar understood this. So this is a storage name, storage engine name. Is this clear? Ravi Kumar? Okay, guys, this flexible document-based structure is why MongoDB is so popular for modern web and mobile applications. Okay, now let us see how it scales in the next coming slide. Okay, look at here, guys, everyone. So scaling and replication. So in this complete slide, I'm talking about scaling and replications. My dear friends, MongoDB scales horizontally using sharding. Okay, so this is horizontal scaling. Here we are using horizontal scaling by using sharding. So data is partitioned in shards for horizontal scaling. Guys, this reduces the amount of data and the number of operations each shard handles. So in terms of reliability, the data is replicated using a primary secondary architecture. Understanding my point, guys? Okay, so what is that primary secondary architecture? Look at here. So write go to primary node. Write go to primary node, which records the operations in the op log. Understand each and every points carefully, guys. So writes to primary in the op log I have mentioned here. The meaning of this is the writes go to primary node, so which records the operations in an op log. So op log is nothing but what, guys? Operational log. And write concern setting is used to tweak write consistency. Okay. So next one, secondaries use the op log to get a local copies updated. And look at your third point. So clients usually reads from primary, but read preference setting can tweak read consistency by directing reads to secondary nodes. So make a note of this, guys. Unlike Cassandra, in MongoDB, data updates happen in place and not versioned or time-stamped by default. So this is the characteristic of its primary secondary replica set model. Okay, so let us take one analogy to explain on this, guys. So think of sharding as dividing library into smaller independent regional branches. I'm repeating, guys. You just think of sharding. Sharding is nothing but partitioning. Okay, partitioning or sharding as a what? Dividing a library into smaller independent regional branches. The replication set is like saying the main branch. What is main branch here? The main branch is primary, right? The main branch is primary. The main branch is where all new books are registered. And the secondary branches copy from it. Very simple. I hope everyone understood what exactly I'm trying to explaining you here. Okay, so now let us look at the visual representation of this, architecture. Then you will understand more. So till here, everything is clear. So whatever the concept I've told, everything is clear with analogy. Yes or no? Can I get quick confirmation on chat box? Crystal clear, right? Okay, now look at here, guys. Look at here, everyone. Okay, guys. This slide gives us a visual perspective of the MongoDB Atlas cloud service. Okay, the image shows a cluster setup with replica set of 3 nodes. Look at here. I have mentioned here. Replica set of 3 nodes. This confirms the primary secondary model with high availability. Okay. And look at the image here. The center image. So I'm talking about the center image. This shows the data model. Data model is nothing but what, guys? Data model is nothing but a document, is it? You see a single listing document from sample AirNB database. So we have taken data from sample AirNB database. Okay, so everything about this listing from its name to what? House rules. So name to house rules is in one shelf contained bson document. So bson document we are using here. And look at the bottom query. You all can observe here. Okay, the bottom query snippet shows a powerful aggregation pipeline being used for text search. What is the text search we are doing here, guys? So we are doing get me top 10 bench front homes. Okay, then what query you are going to use here? So this query uses match. Look at here. This query uses match $match with $search to find bench front. Look at here. To find bench front. So this bench front is a text index. And also along with that, it uses project to calculate a score Okay, project to calculate a score based on relevance. And this is a sort by. So this is sort by score descendingly. And this will limit to 10. See, here I'm performing sorting and this will limit to 10. Guys, this demonstrates that MongoDB's query language is flexible and supports complex analysis like full text search and aggregation. Guys, this visual should help you to connect the theoretical concept of collections, documents, and replica sets. Okay, so now let us explore a more traditional big data concept, MapReduce, in MongoDB context. Okay, I think till here everything is clear to all. So everyone understood what exactly I'm trying to explaining you here. So for this query, we have written code like this, guys. This and all you can practice later. See, we have given worksheet for you people. You start from the beginning, and at one stage you are able to execute this. That assurance I can give you guys. So now I'm moving forward, guys. Now look at here, everyone. My dear students, MongoDB supports the classic big data batch processing pattern. What is that? MapReduce. The general syntax require map function. Correct, no? So which emits key value pair. Am I right or wrong, guys? Which emits key value pair. Look at here. Which emits key value pair. And we have reduce function. So along with that, we have reduce function. What reduce function will do, guys? What is the main purpose of using reduce function here? Because it has to perform aggregates values for the same key, right? So for that, we are using reduce functions also. And look at the concrete example. So what is this concrete example? Guys, count the number of published component per user name. See here I am mentioned here. Count the number of published comments per user name. So this is the command I'm using here, guys. db.post.mapreduce. See, post is nothing but the name of the collection. DB is nothing but database. So this is the standard methodology we are going to use. And I'm calling MapReduce functions here. So inside that MapReduce function, I'm calling the very first function as mapper. Okay. So what this mapper is doing, that is emitting this dot name with 1. And this is the return function. Okay. This I will explain you here. See, the very first one is, see, look at the query here. The query publish true part filters the input to only include published comments. Then what mapper function is doing? Guys, mapper function emits the username. This emits the username and the reduce function sums the count. See, that's why we have written here array.sum values. So this is sums the count here. Okay, so this is emitting username and this is performing summation for the count operation. Count actually. So then what is the analogy, guys? Guys, MapReduce is MongoDB's. See, MapReduce in MongoDB is like having a digital tally counter. What is that digital tally counter? That is nothing but map, right? And that groups all published comments by author and then calculator. What is calculator? Calculator is nothing but reducer. Calculator that tallies the total for each. So hope this is clear to everyone. So now let us see how MongoDB's flexible nature impacts indexing. Yes, guys. Now, because of its flexible document structure, MongoDB allows you to create an index on any field of collections or a subdocument fields. Okay, let us use the example document with a nested fields like address and arrays like tags. Okay, so we are using address here and arrays like tags. Okay, let me go with the very first one. So indexing an array field. Okay, indexing an array field. What array field I'm indexing here? Tags. What is the first line? db dot, look at here, guys. db dot users dot create index. And then I have mentioned tags, tags is tags colon 1. And next line db dot user dot find tags cricket dot pretty. Guys, the index is created on the tags array here. The index are created on the tags array. So this create multi-key index. Understanding my point? This create multi-key index and allowing fast lookup based on any element inside the array. And then what about the second one, guys? Second one is indexing subdocument field. What is subdocument field? That is nothing but an address. See, these two lines are explaining the same thing. Guys, in this case, we use dot notation, correct? No, we use dot notation. Look at here. Address dot city we have used here. Address dot city we have used here. So this is used to create a compound index that spans field nested deep within the document. Guys, the number 1 indicates, and see here, we have mentioned 1, right? And also we have mentioned 1 here, right? Guys, the number 1 indicates an ascending sort order. So this is indicating ascending sort order. Okay, quickly let me take one example, guys. So this flexible indexing allows a user to quickly search for all documents that have the tag cricket. What is the tag we have taken here? So we have taken tag as cricket and are in the city New Delhi. And are in the city New Delhi. Okay, so with an index that covers both. Is this clear to all, guys? Yes or no? Pretty is the name of the function. Pretty is the name of the function. Ravi Kumar, actually, see here, see in both we are using pretty, right? So in both we are using pretty, right? See, for example, db.collection.find.pretty we are going to use. Guys, the pretty function in MongoDB is mainly used to format query results in more readable and structured way. Okay, it is like pretty. What is the meaning of pretty? The same thing. So it adds indentations and line break to the output and making it easier to understand and analyze the complex document. That is the main functionality of using pretty, guys. So when you run a query in MongoDB, the default output can be quite dense and hard to parse. So in that situation, we can use this pretty function. Guys, this pretty method transforms this output into a more visually appealing format. Okay, the same thing we have used here. So this will always display the query result in a formatted and easy to read format. So for that purpose, we are going to use this pretty. So Ravi Kumar, is this clear for you? Is this clear? So have you understood why we are going to use pretty? See in Java, we have println, right? So in Java, we have println. In C program, we are going to use \n, is it? So like that, we are going to use pretty here. Okay. So now guys, let's address the questions of joins in the document database. Okay, so MongoDB joins. Now I'm talking about MongoDB joins. My dear friends, while denormalization, so denormalization means what, guys? Embedding data. See, denormalization is the preferred method. Guys, MongoDB 3.2 plus introduced the capability to join data from two collections using the aggregate framework and lookup operator. Okay, and also by using lookup operator. Have you mentioned lookup operator here? Yes, here we have lookup operator. Okay, you understand here. So this is left outer join. So this is left outer join. I think you have learned the join concept in what? Database, right? SQL, right? Sir, why is tag is square bracket and address is curly brace? That is the syntax, guys. That is the way of writing syntax. Look at here. So yes, listen to me, everyone. See, here I have taken address. So inside address, I'm taking key value pair. Correct? No? So I'm taking key value pair. So this I have put, see here, inside this I have taken key value pair. City, I'm mentioning name. State, I'm mentioning state name. Pin code, I'm mentioning pin code. And the same thing I'm taking with respect to tag also. But where I'm storing this tag, I'm storing this tag value inside the list. Okay, inside the list. Look at here. So football, comma, cricket, comma, badminton, comma, we have taken, right? So everything, see all these three values we have put inside the list, is it? So here the value is city. Only one value we have here. There is no list concept we have used here. So and immediately I mentioned the value. So this is key and this is value. So in this case, so this is completely a list. Okay, this is completely a list. So inside this we have placed three name actually. Okay, so three what we are going to call it as. So we are going to call it as game, right? Okay, tag name we have mentioned here. So for football, for cricket, and for badminton. And the name we have fixed with key value pair. So is this clear? Samanvita? So you are good at what JSON means, then you will understand. So it is a kind of what format. So we are going to use by using JSON. Okay, so yes, guys, I was talking about this left outer join, right? Guys, this is completely left outer join. So look at the what example of joining books collections with the book selling data. So this collection we are joining with book selling data. Okay, so this is the collection name. This is the name of the collection, guys. So book selling data is the name of the collection. So for that, we are going to write this code, guys. So db.books.aggregate, and inside this, we have written lookup from book selling data, local field, foreign field, as copy sold. I'm writing everything. Okay. So here, the very, very important thing is what you have to understand here is from. So from is the foreign collection. So this is the foreign collection. And what about this local field? So local field and also we have foreign field here, right? So local field and foreign field are the join keys. See, look at here. So both the join keys are ISBN, correct? No? And next to that we have as. So as is the name of the new array field in the output document. What is the new array name? That is copied sold. Copied sold is the new array name. So I hope everyone understood this. The result is a simple join document where the copied sold field is an array containing the matching data from the second collection. Okay. So make a note of this, guys. While dollar lookup, say I was talking about dollar lookup, right? So where I mentioned dollar lookup, guys, dollar lookup allows for joins and you should use it sparingly. And it is an expensive operation and is best suited for occasional reporting rather than high volume transaction processing. Okay, the core architectural strength of MongoDB remains the single rich document. No, aggregate function is not a join function. How come aggregate function will become join function? So why you are going to use aggregate, Gautam? Why you people are going to use aggregate? See, aggregation means summation we are doing, means average we are calculating, means then we are going to use aggregate function. Count operation, everything comes under aggregate. How come join will become aggregate function? Hmm? See, I'm talking about lookup. No, lookup we are using, right? See, lookup we are using for the same purpose. That is what I'm telling you. See, lookup allows us for what? Join function. So the same thing I've told you, right, Gautam? So where are you? Hmm? Where have you lost, man? So now you all understood, right? Now all of you understood what exactly join here. That's why you have to concentrate. So now let us recap the strengths of MongoDB before diving into consistency option. So here we have a recap, means we are talking about strengths here. Okay. So recap of what core strengths of MongoDB we are discussing here. Guys, to consolidate our knowledge. So let's recap the core strengths of MongoDB. What are the core strengths of MongoDB? The very first point I have mentioned here is document-oriented DB. Guys, it is flexible BSON structure is its main appeal. Agree? And what is the second point? Flexible consistency trade-off. Flexible consistency trade-off. Guys, if offers, guys, the MongoDB offers various read and write choices for scaling, performance, and durability. Okay, so we will detail these consistency concerns shortly. So for a time being, understand this. This is the second advantage or flexibility of using this MongoDB, or strength of using this MongoDB. And along with that, so we have one more strength. What is that third strength? The third strength is called as high availability. Guys, it features atomic primary re-election on primary failure and or network partition. If the primary node fails, the secondary nodes automatically elect a new primary to maintain availability. Is this not beauty, guys? So look at the images. So images clearly shows the primary secondary architecture. Okay, so now all of them observe here. So writes go to primary with replicas to secondaries. Look at here. So writes goes to primary with replicas to secondaries. Correct? No? You're all observing. So everywhere write goes to primary and replicas to secondary. Yes or no? And look at the reads. Guys, reads typically go to the primary. Reads typically go to the primary, but you can read from secondary using read preference for scale. Understanding my point, guys? So the final image, see, the final image illustrates the election for new primary process after a failure. So this is the election. Okay, so it is selecting for what? New primary. New primary is elected here. See, the concept of consistency in MongoDB is tied very closely to the concept of casual consistency. Yes or no, guys? So here we are using, let me write here, casual consistency. This you will get in your examination. Okay, so let's quickly recap what that means. What is that casual consistency? Look at here, I have mentioned here, casual consistency. Let's quickly refresh on casual consistency. Guys, this model ensures that all operations that are related by casualty are seen by clients in the what? Correct order. The four properties guaranteed in a what single client sessions are. What is the very first one? The very first one is read your writes. Guys, subsequent read operations reflects the result of write operations that precede them. And what is the second one? Second one is monotonic reads. The meaning of this is read operation do not return result that correspond to an earlier state of the data than a preceding read operation. That is monotonic reads. Then what do you mean by monotonic writes? Guys, monotonic writes is nothing but write operations are executed in the order they were issued. And what is the last one? Guys, the last one is writes follow reads. Guys, write operations that occurs after read operation. Okay, so these two are executed after those read operations. Guys, this is very, very important. Yeah, I will give you example. Wait for a while. So next time taking the example. Okay, no need to worry on that. Ravi Kumar. So first try to understand what these four properties. See, I'm telling you here, these four properties guaranteed in a single client session. First one is read your writes, monotonic reads. Third one is monotonic writes, and fourth one is writes follows reads. Okay, now look at the what timeline example. So look at the timeline example. Now you'll understand better, Ravi Kumar. Okay, guys, look at here. I'm talking about P2. Okay, so P2 writes of y is equal to 10. Okay, I'm repeating, guys. So P2 writes of y is equal to 10 is cast by its read of x is equal to 5. Correct, no? See, look at here. Write operation that must occur after read operation. Same thing we are performing here. And let's go to P4. So let's go to P4. What is P4? Can anyone explain what is P4 is doing? So what P4 is highlight means what P4 is violating, guys? What P4 is violating? So is this violating casual consistency? Casual consistency. Correct, no? Because it sees the write to y. It sees the write to y. That is y is equal to 10, but not the write to x. X is equal to 0. Correct, no? Yes, exactly correct, Jyoti. So the effect is seen without the cause here. I hope everyone understood this. Guys, the main analogy is in discussion forum, if you see someone quote another person's comment, so you must also see the original document, original comment. Yes or no, guys? Is this the best analogy to understand the concept? I'm repeating, you have a discussion forum here. Okay, in Taxila, you have discussion forum. What I'm telling you is, if you see someone quote another person's comment, what is that another person's comment? It is nothing but an effect, right? You must also see the original comment. Original comment is nothing but a cause. And what another person comment is nothing but an effect. Understanding my point, guys? So we need to enforce this, guys. So let's see MongoDB example of how this can be violated. Okay, so now I'm showing you the example. A recording is not saved. Why I'm getting this? The recording is going on, right? Yeah, it is going on. Why I'm getting this message? Okay, this is from different class. Okay, sorry, guys. I shocked actually. Okay, I hope everyone are understanding this. Okay, that is what I'm trying to explaining you here, guys. So now I'm moving into the next slide. You just look at here. So this slide shows case one. So what is the case one here? No casual consistency. So no casual consistency in action in MongoDB's replica set if you use relaxed setting. Okay, let's trace the issue, guys. Let's trace the issue. So let me go with point one by one. So I'm starting from here. One. What is one? So in one, client writes order 234 to the primary. Listen to me carefully. So this will give you complete picture on the previous slide. So in very first step, client writes order 3234 to the primary. Okay, this is the first step. Next, immediately primary, see this is the primary sends success back quickly. See, look at here in second step. So this is immediately sending success back. So this is called as low write concern. I'm writing each and every point here. So low write concern, correct? No. And what is the third step here? The third step is the primary. See, this is the primary. So this primary replicates order 234 to the secondary asynchronously. Am I right or wrong, guys? That is the third step. So I'm repeating, guys, the primary replicas order 234 to the secondary asynchronously. And what is the fourth step here? What is the fourth step? So look at the fourth step here. The client immediately reads. The client, see, this is client. The client immediately reads order from the secondary. So this is called as relaxed read preference. Relaxed read preference. And what we are doing in fifth step, guys? Fifth step is secondary returns no result found because replication is too slow. So that's why what it is sending, no result found, it is sending back to the client application. Guys, the client wrote the data, but could not immediately read its own write. Okay, so is this not called as violation of read your rights, guys? Is this not called as violation of your rights? Yes or no? Quickly. I think with this example, you're understanding what exactly I'm trying to explaining you here. Yes or no, guys? Yes or no? Quickly, I want you people to respond quickly on chat box. Okay, now listen to me carefully. The client wrote the data, but could not immediately read its own write. That is called as a violation of read your rights. Correct? No? So let me take one more case here. So I'm taking the second case. This is the second case. What is the second case here? The second case shows how to fix this. Okay, so I have mentioned casual consistency by making read to secondary write. So let me go with the step by step, guys. Listen to me carefully now. The client tells the secondary, I want to read after the time of my last successful write. Okay, that is the first step. Okay, and the secondary waits until the replication stream is applied. So that is waits until T1. So waits until T1. See, look at here T1. Okay, so the secondary waits until the replication stream applied and then returns the correct data. So the mechanism to enforce this waiting and ordering is the read concern and write concern. I hope everyone understood how to overcome this. Yes or no, guys? So I will explain you what is read concern and what is write concern in the next coming slide. Yes, now I'm jumping into next slide. Look at here. I'm talking about read concern. Guys, the read concern defines the level of consistency a client can expect when reading data. Okay, so this is how we control the R, guys. So this is how we are going to control the R in what? R plus W greater than N. Guys, I'm mentioning points here. Look at here, everyone. The very first point I'm mentioning local. Local is the default. Guys, the client reads data available on the local node. So it is also used for clients reading from a secondary in casual consistency session. So this has happened when requested. And what is the second one? Second one is called as available. This is the weakest consistency, right? So this is the weakest consistency, right? Available is the weakest consistency. Okay, so read on secondary, but casual consistency not required. Fastest read, but no guarantees. That is called as available. And then what is the third one? Third one is majority. So majority is the what? Stronger guarantee. The meaning of this is clients reads what the majority of nodes have acknowledged. Best option for fault tolerance and also durability. That is majority. And finally, we have linearizable. What do you mean by linearizable? Guys, this is the strongest possible consistency. So clients reads what has been written to the majority before the read started. Correct, no? So this has to be what? Read on primary and only single document can be read here. So these 2 points are very, very important. So let me take the example for this, guys. See, for your application's main user feed, you might use local for speed. For checking an inventory count before a purchase, you would use majority or linearizable for accuracy. So hope everyone understood this. So now that we know how to control the read side, let's look at the write side with write concern. Okay, this is about write concern. So everyone put your attention here. Guys, see here, so this is complementing the what? Read concern. I think everyone will agree with point. Guys, write concern controls the W. Okay, controls the W in R plus W greater than N. Correct, no? So here it is controls the W. So this defines how many replicas should acknowledge a write operations before success is reported. Correct, no? So one is default. So one is default. The meaning of this is primary only must acknowledge here. So this is fast, but not durable if the primary fails immediately. And what is the second one? Second one is 0. So second one, it is reporting 0. So 0 is nothing but what? None, guys. So none of nodes acknowledge. Okay, it is like fire and forget. So 0 durability guarantee here. And what is the third one? Third order is N. So N is nothing but a specific number N. Okay, so that is including primary and it must acknowledge. And what is the final one? Final one is majority. So a majority of nodes must acknowledge here. So this is mainly preferred for durability. So hope everyone understood this for reports actually. Okay. And see, 2 other key parameters we have mentioned here. What are the 2 parameters we have mentioned here? One is journaling, and second one is timeout. Guys, journaling, if true, so node must write to a disk journal before acknowledge. So this is more durable, guys. So this journaling is more durable. And so here what we have mentioned actually. So we have mentioned less durable, right? So this is not less durable. This is more durable. Okay. So then what about timeout? So guys, timeout sets the timeout for the write operation. Okay. So make a note of this, guys. To build a reliable system. Okay. You combine a durable write concern. So durable write concern means what, guys? So durable write concern is nothing but majority. It is nothing but majority. Okay. Try to understand this. Guys, to build a reliable system, you combine a durable write concern with a consistency aware read concern. Okay. So let us analyze the 4 core consistency scenario using these settings. What are the 4 concerns? See, these are the 4 concerns I have mentioned here. Now look at the what scenario for casually consistent and durable system. Guys, look at the configuration. So what is the configuration we have used here? The configuration is read equals to majority and write is equal to majority. Okay, this is the ideal state where R plus W is greater than N is met. Correct, no? This is met. So during a network partition, a write W1 to the minority node P1 will fail because it cannot reach the majority. Because it cannot reach the majority. And writes and reads R1. So writes and read R1 to the true primary will succeed because it can reach the majority. So hope everyone understood this. Then what is the outcome of this, guys? The outcome of this is the system is casually consistent and durable even within network partition. But you are sacrificing performance due to waiting for the majority. Am I right or wrong, guys? So let us take one example on this. See here, I have taken the example. So this setting is used in critical transaction oriented application. Example, in stock marketing, stock trading, we are using this. So maximum reliability is non-negotiable. Understanding? So now look at the scenario where we compromise a little bit for speed. So this is the scenario I've taken here. Okay, look at here, everyone. So what is the see, it is in this scenario, we are aiming for casual consistency, but not durability. Then what is the configuration? Configuration, look at here. Read is equal to majority, write is equal to 1. Guys, during network partition, look at here, everyone. During network partition, a write W1 to the majority node P1 may succeed. Because why it may succeed? Because we have taken write is equal to 1, right? Write is equal to 1, right? But it is not durable and may roll back later. This may roll back later. And second line, a read R1. I'm talking about a read R1 will succeed only on the true primary P2 because read is equal to majority here. Then what is the outcome of this, guys? The outcome of this is it is casual consistent. Why it is casual consistent? Because the read waits for the majority, but not durable with the network partition. The trade-off is fast writes, slower reads. Correct, no? So I'm going to take the best example for this, guys. I'm taking the example of Twitter post. A post is written fast. The post is written fast. Why it is written fast? Because write is equal to 1 here. Write is equal to 1. The post is written fast, so you see it immediately. If the node fails, the write may disappear, but if you refresh and see it, it is durable. The user accepts the risk of having to repost. Correct, no? Guys, next we sacrifice even casual guarantee for maximum read performance. Look at here. The next slide is explaining on this. Correct, no? So here we want eventual consistency with durable writes. So we want the data to be safely written, but we can accept a stale read. What is the configuration we have taken here, guys? The configuration read is equal to local, write is equal to majority. Correct, no? During network partition, you can see the diagram also. During network partition, a write W1 will succeed only for P2. Only for P2. Why only for P2? Because we have taken write is equal to majority. What is this, guys? The write is durable here. Correct, no? And what about R1? What about R1? Guys, the read R1 will succeed on P1. This is succeed on P1 because read is equal to local. We have taken read is equal to local. Guys, P1 is isolated node. So, and its data is stale here. Okay, then what is the outcome of this, guys? So we get slow, durable writes and fast non-casual reads. So the system is eventually consistency. I hope everyone are understanding this. Let me take the example here. The example for this is review site. Okay, review site. Guys, A new review write should be durable. But a user reading the page does not need a casual guarantee as long as the new review appears sometime. That is called as eventual consistency. I hope everyone are understanding this. And yes, guys, our final scenario is the fastest but least durable. So can anyone guess what we have to do for fastest and linear durability? Yes, can anyone guess? What would be read? What would be write? Now, yes, I have explained you three, right? So now you can easily guess. So now I'm talking about eventual consistency, but no durability. So we sacrifice everything for the speed now. Then what is the configuration we are going to use? Yes, anyone? So read is equal to local. Then what about write? Samanvita. Yes, your answer is correct. So read local. What write? Huh? I'm not getting any response. Am I audible, guys? You're all understanding what exactly I'm asking you all. Yes, I think write will be delayed. No, what is the value? What value we have to set? Hmm? Guys, look at here. So read is equal to local, write is equal to 1 is the configuration we are taking here. So this is the fastest setting, guys. Okay, however, the writes are also not durable and maybe what rolled back. So maybe rolled back, correct? No. The example is real-time sensor data feed. So I'm taking the example for this is real-time sensor data feed. The system needs fast writes to keep up with the rate. Okay. And what is the next one? Read should get as much recent real-time data as possible. That's why we have taken read is equal to local here. Okay. And data may be dropped on failures. Okay. So which is acceptable for stream processing where the next reading is only a second way. Guys, this wraps up our deep dive into the document database and its tunnable consistency. Okay. And this is a very important point, guys. So remember, see, you have to remember. So these four scenarios. So try to remember these four scenarios. So they are the blueprints for designing the core data layer of any modern big data application. So you go back to the recording and go through the explanation I've given, guys. That is very, very important. So is this clear to everyone? Yes, maybe yes. You people are going to say, sir, it is confusing. But you go through the recording, guys, you will understand it. Okay. So hope this is clear to everyone. Now it is a time to move on to the different types of data model that focuses purely on relationships. So that is nothing but your graph databases. So shall we start with graph databases? Quickly, guys. Quickly, I want you people to respond. So still I have not completed 9th session concept only, guys. Sir, break. Jyoti, why break? Then I will extend the class. Is it okay? So now I'm giving you 10 minutes break means. So I'm going to extend the class. Is it okay for you? See, many of them are saying no. So even Jyoti is saying no. Okay, so let me complete this. Okay, let me complete graph computing. So still I'm pending with what the previous concept, right? So I have not yet started with the 11th session concept, and then I have to start with the 12th session concept. So still we have to complete a lot. Okay, so before that, so let's jump to the graph computing, guys. So we are transitioning to our third major NoSQL category. What is the third major NoSQL category? That is called as graph databases. Guys, these are essential for modeling interconnected data. Okay. The fundamental model is the property graph. The fundamental model for this is property graph. So data is represented as three components here. What are those three components? The very first component is called as vertices. Okay, so vertices are nothing but what, guys? So vertices are nothing but nodes. Okay, so entities like person, movie, so everything is comes under vertices or nodes or entities. And what is the next one? Next one is edges. So edges are nothing but relationship. Edges are nothing but relationships. So that is nothing but connections between vertices. Okay, connections between vertices. See, for example, friend of, daughter of, mother of. These are all the best example, correct? No? And the third component is properties. Third one is properties. So properties are nothing but, guys, key value pairs on both vertices and edges. So let me take the example. So name I'm taking as Alice, or role I'm taking as actor. So this is the key value pair on both vertices and also edges. So this is called as properties. Guys, these three. So these three are very, very important for data. Try to understand this. This is important. Then when to use a graph DB? So when we have to use a graph DB, guys, a relationship heavy data set with large set of data items. So for example, RDBMS joins or two slow means, then you can use this graph DB. That is the very first point. And the second point is queries are like graph traversal. Guys, you need to keep query performance almost constant as database grows. The time depends only on the length of the path, not total number of nodes. So in that situation, you can use GraphDB, and a variety of queries may be asked. Variety of queries may be asked, and static indices on the data will not work. So in that situation also, you can use GraphDB. Let me take the analogy, guys. So GraphDBs are perfect for modeling a social network. So you can find a friend of friend of friend in milliseconds. So which an RDBMS would struggle to do efficiently. So in that situation, you can use your GraphDB. Look at here. So name Alice we have taken. Friend of Bob, friend of Charlie, friend of Daviana. Correct, no? So in this situation, you can use your GraphDB. Guys, this data model is incredibly powerful. Okay, so now let us see the different ways to store this graph structure. So this is the example, guys. Look at here, everyone. So I'm talking this as native versus non-native graph storage. Guys, the distinctions between native versus non-native graph storage is extremely important for graph performance. Okay, so let me start with the very first one. What is the first one? Non-native graph. Guys, non-native graph computing platforms rely on external databases for data storage. External databases for the data storage. See, example, the best example for this is Tinkerpop. Tinkerpop can store data in Elasticsearch or in Cassandra. See, I have mentioned here Elasticsearch or in Cassandra. Okay, and also in this approach, you need extensive indexing. Try to understand this. So in this case, you need extensive indexing. Why it is required? To find the next node in the traversal, so which can be slow. And next I'm jumping into the second one, that is native platform support. Guys, native platform supports built-in storage. So which is optimized for graph structure. The best example for this is Neo4j. Okay. And also the native approach is much faster because why it is much faster? Because adjacent nodes and edges are stored closer for faster traversal. So this is called as index free adjacency. Index free adjacency. The cost of finding a neighbor remains constant here. Okay. And one more very, very important thing is, guys, the native approach scales as nodes get added. Okay. Make a note of this, guys. For true high performance graph processing, always favor a native platform like Neo4j. Okay, even Neo4j is installed on your virtual lab. You can try on Neo4j also, guys. Now let us see what a native graph query language look like, starting with Neo4j Cypher. Okay, so now I'm trying to show you with Neo4j Cypher. So everyone concentrate here. So let's dive into the most popular native graph database, so which is called as Neo4j and its query language. What is the query language name? The query language name is Cypher. Guys, Cypher is a declarative language for graph query. Okay, it uses ASCII art style that makes queries very intuitive. Okay, let us look at the what simple query here. So let us look at the simple query. Look at the simple query, guys. This is very easy to understand. So I have written match, open simple brace, colon, person, and again I've opened flower bracket. So inside flower bracket, I've written name, colon, Tom Hanks. And I've closed this, close the simple brace, hyphen, acted in, see, colon, acted in I've taken, see, for person I've taken colon person, for acted in I've taken colon person, tends to, see, inside simple brace I've taken M movie, where I've written where M dot released greater than 2000, return M limit 5. Limit 5 means only 5 data I'm looking for. Guys, each and every point I'm going to explain you now. What match is doing? Guys, match is doing finding. So this is find a pattern. So this is find a pattern. What is the next line? Colon person. I've taken flower bracket. Inside that I've written name Tom Hanks, right? So this is the starting node. Okay, the starting node. A person named Tom Hanks is the starting node. Try to understand this. Okay. And next one we have taken acted in. So what is acted in? Acted in follows the directed relationship acted in. And next to that we have taken M colon movie, right? So this arrive at a connected node. So what is arriving here? A movie is arriving here. Okay, arrived at the connected node. And last line we have taken where M dot released greater than 2000. So this filters the result. This filters the result. I hope everything I've explained you. Guys, look at the image. The image shows the visualization. So here we have about different circles, right? So we have two different types of circles. So one is blue circles and second one is orange ovals. So we have taken two, right? So blue circles are person nodes. So these are all person nodes, guys. Okay. And orange ovals are movie nodes. So these are all movie nodes actually. Okay. And red arrows, see, we have somewhere red arrows. Where do we have red arrows? So we have only arrows, right? So see, all the arrows, let me consider it as arrows. See, all the arrows are relationship here. So this is how we are going to represent, guys. So let me take the analogy to explain this. You are simply describing the pattern you want the database to find on a graph. That's all. Now let us look at how we can change these patterns for more complex traversal. Okay, so now I'm talking about more queries. My dear friends, the power of Cypher comes from chaining patterns. So query one, let me start with the query one. What is the query one? This is the query one I'm taking here. This is the query one I'm taking here. Find movies that Tom Hanks acted in and directed by Ron Howard, released after 2000. So what is the query we are going to write, guys? You look at the query. So this is the query we are going to write. So person name is equal to Tom Hanks, acted in movie name, person name Ron Howard, directed where M released after 2000. Return M limit 5. M limit 5 means it is storing only 5 values. Guys, we link two separate pattern. So where we have linked, guys, can anyone guess where we have linked? What delimiter we have used to link to? Can anyone guess? So what delimiter we have used here, guys? We have used comma operator, right? Look at here, everyone. So here we have used comma operator, correct? No. So we are linking two separate pattern using this comma operator to the same movie node, correct? No, see, same movie. M is equal to M is the same here. And the result is an intersection of two relationship path here. So hope everyone understood this. So go through the second query. So this is the first query. So I'm talking about next query here. Query 2. So who were the other actor in the movie where Tom Hanks acted in and directed by Ron Howard, released after 2000? Who were the other actors? I'm talking about other actors. Then what we have to do, guys? So the same code I'm writing here. Look at here. Person named Tom Hanks acted in M movie, comma. Person name, again, person name Ron Howard, directed movie, person acted in, where M dot released greater than 2000, return P limits 5. So where we have made the difference? What exactly the third pattern we have used here? Can you all observe? So can anyone guess, guys? Do we used one extra pattern here? Look at here, guys. This is the first pattern, right? This is the first pattern we have used. And next we have taken another pattern here. And after that, we have taken one more pattern here. Look at here. See, P person acted in. Correct? No. So we have added one more pattern here. So we add the third pattern. We ask the database to find any other person P. Any other person P who also has the relationship with acted into the already found movie M. Already found movie M. Guys, this is highly efficient as the database is simply following pointers. Correct? No? Is this very easy? Yes or no? Now let us quickly look at another major graph computing platform, that is Tinkerpop and its language Gremlin. So we are not using this Tinkerpop in your lab, guys. But yes, it is there in your syllabus. I'm explaining you. That's it. Okay, look at here, guys. So now I'm talking about Tinkerpop. Or we can call it as Gremlin. Okay, we can call it as Gremlin. Otherwise, Gremlin is another one. Okay, see, the final piece of the graph puzzle is Apache Tinkerpop. Okay, guys, Tinkerpop is a computing platform that connects to graph databases. But it is not a database, guys. It is not a database. Through its built-in Tinker Graph stores in-memory data only. So this stores in-memory data only. Guys, it is a query language in Gremlin. Okay, so what is Gremlin? Guys, Gremlin is an imperative traversal language that uses a chain of steps to tell the database exactly how to walk the graph. So let us understand this concept by using queries here. So we have taken two queries, right? Let us start with the very first query. So this is the sample queries we have taken here. So movies where Tom Hanks has acted. Look at the code here. Small g, capital V function we have used here, has label, person dot has name, Tom Hanks, out e acted in, has label movies dot values name. Guys, you start you start at all vertices. So this is indicating all vertices. G dot V means, so V, capital V is nothing but vertices. You start at all vertices by using G dot V and filter to the person. Okay, filter to the person. So for that you are using has label and filter by name. And after that you are filtering by name also. What is the name you are filtering here? So filter by name has Tom Hanks and walks to the outgoing edge. See, this is out edge is nothing but outgoing edge. So walks the outgoing edge out E and returns the name. So returns the name by using values. So hope this is clear to everyone. Is this clear? And let us take the second query here. So this is more complex chain of traversal. So this is showing how to instruct the graph to walk out, back in and out again to find the common node. So G dot V, so we have taken all the nodes as label person has name Tom Hanks, out E, look at here, out E acted in E, again we are going inside, directed and again has name Ron Howard, out E directed, finally we are extracting the values. So this is little bit complex chain of traversal, guys, but this is also very easy to understand. So what is the analogy here? Guys, cipher is declarative. So cipher, what we have seen, cipher, that belongs to Neo4j, that is declarative. So that is saying what you want, but Gremlin is imperative. So what Gremlin is saying, guys, so Gremlin is saying how to get it. Guys, this concludes our NoSQL deep dive. So next slide is completely summarizing the concept what we have learned in NoSQL. Okay, this is a summarization. So let's go through this. NoSQL databases are useful when you have a deal with large data sets and you may need geographical distributions and you have no need for ACID transactions, and instead of what? Instead need flexible consistency means you can use this. And you now have choices between key value, column based, document based, graph based data stores. Okay. So specifically when I'm going to talk about graphs. So graph databases and computing models are very suitable when data sets are relationship heavy. And complex relationship centric queries are possible here. And graph traversal cost can be kept stable with data graph. Okay, then what is the motivational takeaway for NoSQL? My dear friends, mastering NoSQL is about understanding trade-offs. You are trading rigid schema and complex transactions for speed, scale, and flexibility. So this is the mindset of a modern big data architects, guys. So I hope till here everything is clear. Is this clear to everyone? Shall I get quick confirmation and chat box? I have not yet started with cloud computing. This is 11th session concept. Look at here, guys. This is 11th session concept. So next phase, I am jumping into what 13th session, but still I'm not completing 12th session concept. So I'm pending with 11th session concept and also 12th session concept. I think, have you learned cloud computing concept, guys, before? Have you learned cloud computing concept before? You have separate subject on cloud computing, right? Then it is completely introduction, guys. Completely introduction we are giving in 11th session. So maybe yes, next class I can go a little bit faster to complete the syllabus. So already you people are familiar with this, right? Then I can go very fast to complete cloud computing. So yes, guys, I'm taking extra class on this Saturday. So Saturday evening, I'm taking the extra class. So can you give me a comfortable time when I can take extra class on coming Saturday? So I have to complete 11th session concept. I have to complete 12th session concept. So afternoon, please, I want each and everyone to respond to this, guys. Is afternoon is okay for you all? Afternoon, what time, Tanya? No, 10:30 to 12:30 not possible. Actually, morning 8:30 to 10:30 I have another class. Okay, 8:30 to 10:30 I have another class. Sir, post lunch. Yeah, suggest me a time around 3 o'clock. So for me, no problem, guys. Evening, I don't have any class. Okay. So 1 p.m. Okay, 1 p.m. Any other time? Gautam is saying 3 p.m. 3 p.m. is okay for me. So 12:30 is not possible, Ajit. Yeah, Ravi is saying 5 o'clock. So even I am okay with 5 o'clock, guys. So if you are coming at 5 o'clock means that is okay for me. So 5 o'clock, 6 o'clock is good for me, guys. Even I need rest, right? Someone with a 1 to 3 is not possible. You suggest me after 3. 3 is also okay. 6 is also okay for me. So 11th session, we have only 30 slides, guys. So that is the introduction on cloud computing. So I will take very less amount of time to complete that. Okay, 1 second. I'm getting one more message here. Let's keep the same time like today. So 5:50. Okay, Niklesh is saying 5:50. But maximum people are saying 3 o'clock. So if you people are okay with 3 o'clock, I will conduct class at 3 o'clock, guys. So is this okay for you all? Okay, majority of the people are saying 3. So I will go with 3 o'clock. So 3 to 5. I have to complete 11th session concept. I have to complete 12th session concept. And this week, yes, guys, this week you have 2 challenges. So one, we are starting quiz 2 tomorrow. So I'm giving you 5 sufficient day to complete your quiz, guys. Again, it is a 40 minutes quiz. So you go through the quiz, it will carry 5% of your marks. That is 5 marks. And it is compulsory. Okay. So that is one thing. And second thing, I'm releasing assignment this week. So probably Thursday, I'm going to release the assignment. So I'm going to give you sufficient time to complete the quiz, guys. Okay. So I'm going to give you minimum of 15 days time to complete your quiz. So no need to worry on that. And it is a group project. See, I'm repeating on the assignment part, guys. So let me write here. Let me take a separate slide to explain on this. 1 second, guys. Guys, actually, this is how I'm going to give you the assignment. Your assignment is having 2 parts, part A and part B. So part A is a kind of guided project. So here, compulsorily, you have to use HDFS, MapReduce, Hive, Pig, and HBase. So this is compulsory. You have to use this compulsorily because I have framed problem statement based on this. This is the one requirement. And the second requirement is data set. Guys, data set you can download from any of the resources like Kaggle. You can download from Kaggle, or you can generate synthetic data. Okay, you can generate synthetic data. This is left to you people, guys. So either you can take the data from Kaggle or you can generate your own synthetic data. So for the given problem statement. So this is the second thing. And yes, guys, on each and everything, I have given simple queries to use all these tools. And the third important thing is you have to use virtual lab. You have to use virtual lab compulsorily. You're not supposed to do this outside the virtual lab. Suppose you have any problem with virtual lab, you send a messages to Santosh. Okay, I'm going to send you the email address of that person. Okay, you send a mail to Santosh, or else, so in worst case, you can use your cloud computing lab. Okay, so you have AWS connection, right? So even in AWS, you can download all these tools and you can work on that. You can download instance on HDFS, MapReduce, Hive, Pig, and HBase. You can work on that. But that is at the end, guys. But you have to use compulsorily the virtual lab. So here what I'm going to do, suppose you people are using virtual lab compulsorily, then I'm going to give you 2 marks freely, guys. Okay, so we are going to check the log details. So once you people are utilized the virtual lab, then you are going to get 2 marks. So then we are going to see we are going to evaluate your assignment for 18 marks. So is this clear? But this is my compulsion, guys. You have to use the assignment. This is the first part, and this part carry 10 marks. So this part carry 10 marks and it is group project. So this is group project. Is this clear to everyone? This is about part A. So have you got clarity on part A? Sir, for part 1, we have to use all 4 tools. Yes, you have to use all 5 tools, sir. HDFS, MapReduce, Hive, Pig, and HBase. I have framed question based on this, guys. See, I'm going to give you one problem statement. So for this problem statement, I'm going to ask you the subtask. You have to load this data set inside the HDFS. Then you have to write a MapReduce program to do this. Next, you have to write a Hive program to do this, Pig program to do this, HBase to do this. So like that, I have given a query. I have given what? 5 to 6 subtasks that you have to perform. That's it. So hope this is clear to everyone. Yes or no? No, Ravi Kumar, groups are already formed. Ravi Kumar, groups are already formed. See, I have asked you people to what? Create a group long back, right? See, groups are already formed. You just go and find your group. That's it. See, you have not created your group means we have pushed you into some other group. You have to go with your group members. That's it. So this is part A. Part A is clear to everyone. Part A is clear to everyone. So now I'm going to say about part B, guys. So if you have any query on part A, please do ask me again. Sir, we have currently group for other assignment. I'm not getting your question, Ravi Kumar. Once again, let me do one thing. So I'm going to enable your mic. Yeah, Ravi Kumar.
Yeah, sir. So thing is, currently we have formed 4 or 5 people of group for which we are using for the all the assignments from all the other subjects.
Hmm.
So that is something we coordinating and working on the project is quite easy. Now, thing is, whatever groups are created here in big data, the people, all people are different. So we all which we are using, I mean, the members which we have in the other subjects, we all are scattered to the different groups. So what we wanted is we wanted to be in same group for the big data as well.
But Ravi Kumar, I have given the option to select your own group, right?
Yeah. So unfortunately, when we checked almost around 2 weeks back, we saw ourselves into the some random groups actually.
No, actually, you go through the announcement. Long back we have announced. So
Yeah,
we
yeah, it
have
was.
waited for that for a what long time.
Yeah, it was announced, I think, in the end of the August, I believe, August or
Hmm.
Sorry, September.
Hmm.
But
Now we are in October.
yeah, but earlier we were occupied in the midterm exam, so we didn't focus on that. So that's the thing. What I'm
Then you do
requesting.
one thing. Then you do one thing. Okay, you discuss with Kamlender sir. Okay.
Kamalinder
Okay,
sir.
he is my TA. You discuss with him. So
Uh,
he is going to help you regarding
okay.
this.
And
Okay, you write a mail to Kamlender.
Mhm,
So still you people have time. You write a mail to Kamlender
mhm.
and address your problem. So he is going to help you on that.
Understood. And can we have the max capacity of 5 or instead of 4?
No, no, only 4. It is
Only.
restricted to 4.
Okay. Okay. Sure,
Okay,
sir.
not
Okay.
5 members.
Understood. Kamalinder sir, you mentioned.
Yeah, Kamlender.
Okay. Yeah. Thank you, sir.
Okay, I'll do one thing. I will post you the email ID of Kamlender sir. Wait a minute.
Sure. You understood the what
Yeah,
I'm
I
trying.
understood, but it is too late, Ravi Kumar. See, for that only we have waited for a long time. See,
Mm.
to create a batch, you people have not done that job. Okay, I have posted email ID of my TA. You discuss with him, okay?
Okay. Sure. Yeah. Thank you. Thank you, sir.
You send a mail to him, he will address your problem.
Okay. Yeah.
Okay, this is the part here, guys. So if you have any doubt on this, please do ask me. Otherwise, I will move to the second part. Shall I? Okay. So part B is, yes, part B is again for 10 marks. So this is situated learning. Situated learning. So situated learning means, see what you people have to do. See, you have a 4 members in a group. Okay, let me call person 1, person 2, person 3, and person 4. Okay, 4 members. All 4 members are working in our different organization. So here, what you have to do, you have to take one of your organizational problem and then you have to solve the problem of your organization. You can use any tools, guys. Whatever the tools I have taught in big data, you can use any tool. So how we submit part A via screenshot? I will tell you. Samanvita, I have given complete instructions on your problem state. What document? So you have to only paste your snapshot. After working, you have to paste only your snapshots. So that document and all, I will show you in the next coming class. Probably Saturday, I'm going to show you. Okay. Otherwise, by Thursday, we'll get to know, guys. So what type of document I'm submitting you, everything you will get to know. So here in situated learning, you have to define your organization problem. This is very, very important. You have to define your organizational problem and you have to solve that organizational problem by using any 3 tools. So this is left to you people. You can use any 3 tools which I taught in the big data system class. And steps and all, everything I've mentioned in situated learning part, you follow that. Only this much, guys. So either you can take your own problem or you can do one thing, or what you can do. So all 4 can talk to each other. You can go with one problem. That is also okay for me. Better you always take the individual organization problem and submit it separately. Okay. So what you people have to do at the end, you have to take part A, convert it into PDF format and take part B. Suppose in part B, you have 4 different problems. You take 4 different problem in PDF format, merge both and submit your problem. That's it, guys. So this is what you have to do. Okay. So you have 4 different problems, convert it into PDF, merge it with what part A problem. Part A is grouped project. This is individual project. You merge everything and submit it to the Taxila. That's all, guys. So this is what your part B. So part B carries again 10 marks. So 10 marks for part A, 10 marks for part B. So is this clear to everyone? So if you have any doubt, you can raise your voice, guys. Yeah, detailed solution only you have to give, Pradeep. So better, guys, see, after completing your organizational problem, you take acknowledgement or certificate from your higher ups. Okay, from company. So anybody is guided something means, then you can take the letter of recommendations from the person also. Okay, that is also encouraged, guys. So that will give you more weightage to your situated learning project, right? The main intention behind this is, see, whatever the concept you have learned, that should be implemented in your organization. That is the main thing I'm expecting from you people. Yeah, individual 4 problems. Yes, sir. That is better. Always go with individual 4 problems. Because 4 members you have means 4 members are working in a different company, right? All are not from the same company, is it? Pradeep. Pradeep, you are there? You can talk to me. I have unmuted you. Guys, hope you all understood. So the assignment, what you people have to submit. Yes or no? Yeah, you can go for single also. Single detailed also not a problem for me. No, you use minimum of 3 tools. Tanya, I'm not going to, yes, you can use any number of tools. Minimum 3 tools you have to use. That's it. You use all the tools, whatever I have taught. Not an issue. Clear? Yeah, format of report, everything I have given, guys. No need to worry. Shall I show one assignment problem? So if you want, I will show you one assignment problem for you people. Is it okay for you all? So do you have time? Yeah, after this class, you will get all the information in Taxila. Look at here, guys. So this is how I've designed the problem statement for your assignment. See here, you have everything. So let me show you the very first one. So this is the assignment part I have designed for you people. So the very first part is guided project for 10 marks. So I have given description on market basket analysis. And I have given objectives of this problem statement and prerequisite. See, it is already installed. So in your virtual lab, everything is ready. No need to go with prerequisite, but I have mentioned here. And this is the information about your data set and where exactly you are getting this data set. That information also I have given here. And or else you can create your own data set also by using synthetic synthetic data set also you can create by using Python programming. That is also left to you. Okay, it is not compulsory. You have to mention 3 to 4 millions of rows, guys. That is not compulsory. Okay, see here I have mentioned, but no, don't go with 3 to 4 millions rows. Okay, 50,000 rows not required. So simply I have mentioned there. And next one, it is industry relevance project. And here, see, I have given assignment number. You have to mention your respected assignment number. So this copy I'm going to give you in Excel format. You go to Excel format, you find your assignment number. So based on that, you have to write your assignment number and group name also have to mention here. This is the contribution table you have to fill. See, suppose you have 4 members in a batch means. So I'm showing you here, guys. This is very, very important. Suppose you have 4 members in a batch means you write one, the name of the person, ID number, and contribution you have to mention 100%. You are not supposed to mention 25%. Suppose you are mentioning 25% means you are going to get 25% of 20 marks. Because I need I need each and everyone's involvement here. So that's why your involvement has to be what mentioned here. That is 100%. And second person name, ID number, 100% you have to mention. See, for all 4 members, you have to mention 100%. This is compulsory. And here I have given problem statement. Look at here, everyone. So this is the problem statement I have given. See, task to perform HDFS plus MapReduce. This is I have mentioned here. And second point, MapReduce. See, first thing is you have to ingest the data set to your HDFS, and then you have to verify verify with this command. This is the first task, guys. Second task, you have to write a MapReduce job to count order per day of week and produce output in this folder. See, even I have mentioned folder name also. And next, with respect to pig, I have given one query. With respect to hive, I have given one query. With respect to HBase, I have given one query. So what you people have to do, you have to write this query. You have to take the snapshot. So take the what next line. I'm going to give you the Word format of this file, guys. I'm not going to give you PDF format. So you click, see, you press enter here, and then you submit your snapshot. So supporting snapshot, you have to submit for each and everything. Okay, this is the problem statement I've given. And this is your part B. So part B is situated learning project. This is for 10 marks. So even I have given rubrics also. You all can observe here. The very first thing is you have to identify the problem statement. So that will give you 3 marks. See, here I have mentioned step by step. Clearly describe the business context and domain. Identify the specific data problem challenge. Explain why this is big data problem and define the objectives and expected outcomes. So press enter here. You paste your work here also, here also, here also. The same format you have to use here. Next, you have solution design. So solution design I have mentioned with the bullet points. And next to that, you have proof. So proofs are nothing but snapshots. Okay. So implement a small but meaningful part of your solution. Use at least 3 different. See, this is compulsory. You have to use at least 3 different Hadoop tools from the course and demonstrate working prototype with the sample data and show primary result of each and everything. So this is what I have mentioned, guys. And deliverable for part B is problem statement, business context, data landscape description, solution architecture diagram. These are all the supporting things you have to submit. Okay, for each and everything I have mentioned here. Suppose you are writing code means you have to submit your code. Data set also you have to submit. Screenshots also you have to submit. Okay, and final presentation I have mentioned here. You create PPT on this. You create PPT on this and you convert it into PDF and submit it. Okay, so it is not compulsory you have to give presentation, but yes, this is compulsory you have to write. And everything I have mentioned here. So last working date, everything I have mentioned here. And what and all you have to submit, everything I have mentioned here. So you are going to get 20 marks for this. And along with this, I'm going to send you OSHA lab access for BDS lab also. So by using that, you can get to know how to interact with OSHA lab. Is this clear to everyone? I think this is perfectly designed, right? So now you have, I have what switched on your mic. You can express your opinions. See, I'm giving you 15 plus days of time, guys. So last date to submit your assignment is 18th November. You are going to get 15 plus days of time. This Saturday only I'm releasing the problem statements. So is it okay for you all? This is easy, right? For group project, it is easy, right? I am not getting any responses, guys. Ravi Kumar, Jyoti.
Sir, sir, if we if I summarize it, part 1 and part 2. Part 1 will be kind of group, and part 2 will be in individual. Right? And part 1 is something where what you mentioned is a guided one, like we need to present the screenshots and all, whatever the questions, the scenario you gave and the relevant questions. We for each of the question we have to put the screenshot under the document. Correct. That is correct. Part A. And for part B, something kind scenario is something we need to pick it within our organization, and then accordingly whatever the criteria is, we have to work accordingly. That document submission.
Exactly.
Understood. Thank you, sir.
Pradeep, I can't give time till 25th of November because so we have to complete the evaluation. So before your 15th session, that is the requirement. That's why I'm releasing very soon, guys. So this Thursday or Wednesday, I'm going to release your assignments. So I'm going to give you sufficient time to complete your project. So try to understand, Pradeep. So before your 15th session, we have to complete the evaluation. We have to submit EC1 marks to the higher ups. So that's why I have to complete everything before 18th November. Now, part 2, Tanya, part 2 is not a group project. I'm not saying it is a group project. Suppose, see, you are belonging to what different organizations means, then you have to take individual problem. So, or else it is not possible means, then you can go with group project. That is what I've told, Tanya. So better you people go with individual project. Tanya, is this clear? Varun, is this not sufficient time? I'm giving you, see, usually in your handout, we have mentioned only 10 days. So now I'm giving you what, more than 10 days. Tanya, you are not from, see, that is why I told you, right? Because not everyone is from tech project means not an issue. So in that case, you can take group project. Okay. Better you people take the recommendations from your any of the company people. That is important. So that later also you can attach with the assignment document. So if you are doing both part A and part B in a group, then single report for part, yes, you have to submit single report. Any one of the person has to submit this report actually, Pradeep. So any one person has to submit the report in your group, not all. So that's why I've told you here, right? You collect, see, the person who is submitting has to collect PDF format from member 1, member 2, member 3, member 4 and merge with part A, and then you have to submit. You have to submit only single document. You're not supposed to submit separate documents. This is clear, Pradeep? That instruction, everything I have mentioned there. Have you seen here? See, at the end, I have mentioned all the instructions. See, here I have mentioned all the instructions. So file name also I have mentioned here. You have to take the same name. So this is part A. So this is part B. And then you have to mention group number with zip format. The same naming convention you have to use in your documentation. Is this clear? Guys, this will give you almost 30 marks. So EC1 is giving you what? 30 marks very easily. But I want you people to give a justifications to your work. That's it. See, this is an opportunity, guys. This is an opportunity to take a problem from your organization and you have to showcase what you have learned in the data science class, big data system class. So where to get the group details? That group details already framed. See here in this you have group details, right? Where is the group details? Yeah, here. So you click on this option. Wait a minute. Better you talk to your group members, guys. See here, so many people are having 5 members in a group. So one has to come out from here, guys. Otherwise, we only remove. Better you people come out of it. See here, you have all the group informations. See here, again, group number 22 is having 5 members. So you discuss with your group members and come out of it. Okay.
Sir, there is no option to come out on your group actually.
Is
We are
this?
yes, we are unable to get out of the.
Then do one thing, Ravi Kumar, you write a mail to Kamlender, you will do the task. So
Sure.
from backend. Okay. So
Okay.
that's why you people have to contact this email ID. If you have any problem, you contact this email ID and put CC to me. Okay. I will follow on that.
Sure, sir.
Is this clear?
Yeah.
So you finish everything by this week. This group and everything you have to finish by this weekend. Then it will become very easy to communicate with your group members and you can complete your assignment on time. We are not going to extend time, guys. We are not at all going to extend the time. So strictly we are following 18 November as the last date to submit your assignment. But as I told, instead of Thursday, I'm going to release assignments on Wednesday. Okay. So that help I can do you guys. That's it. So is this clear? So any opinion on assignments? So other than Ravi Kumar, we have Tanya here, Niklesh here, Varaprasad here. Please inform to your friends, guys. So it is there in your recording. So whatever the thing have conveyed, so everything is there in record. So please inform to your friends to go through this.
Everything is good, sir. It's just all a lengthy, too many things. I mean, it's all together. This is one subject, and then there is a CC, then there is a parallel IPDB first. So there are 3 parallel assignments will be. So and the
Correct.
parallel are all working also.
Correct. I can understand, but yes, it is mandatory. You have to complete this also, right? Because you are getting 30 marks only for this, is it?
Yes.
Yes, guys, that's all from my end. So this Saturday, I'm taking extra session. So at exactly 3 o'clock, we'll meet you on next Saturday. Ravi Kumar, can you wait for a while? So other than Ravi Kumar, everyone can leave. Thank you all, guys.
Sure.